Hey math students! Today we're going to be learning about the metric system, which is a unit of measurement that was adopted by the French in 1795, and it's used almost all over the world. Almost every single country in the world uses this system of measurement, except for three: Liberia, Myanmar, and of course the United States. It's so popular though, it is worth knowing about. So let's get going. We're going to start off first with a warm-up. So go ahead, pause me, and give this warm-up a try. Alright, welcome back. Here's what I got. Ooh, there it is. So both of these problems involved converting between feet and inches. So at the very top, I wrote the conversion factor between feet and inches, which is that 1 foot equals 12 inches. So to turn 2.5 feet, I multiplied by 12 inches over 1 foot, which is just the same as multiplying by 1, right? Since those things are equal to each other. So I was really just multiplying by 1. 2.5 times 12 is 30 inches. And then to turn inches into feet, so I use the same conversion factor, but I flip it. So I have 1 foot on the top divided by 12 inches, still just multiplying by 1, and I got 10 feet. Okay, so kind of practicing our converting before we learn about another unit of measurement. Okay. So this lesson is done in conjunction with the culinary class. So I'm teaching specifically about math that can be used in culinary. So I bring up that both scientists and chefs use 3 common units of measurement. And so we're going to be looking at length, mass, and volume. But first, length. And the base unit that is used in the metric system is meters. So instead of feet or miles, we're going to get used to talking about meters. Okay? And lengths can be used like using rulers or some sort of straight line, right? Length is measured one-dimensionally. A meter, just for reference, is a little bit more than a yard. So a tall human male, or a tall human in general, we could say is 1.72 meters, right? And then an emperor penguin is 1.2 meters, okay? So 1.2 meters is probably like 4 feet, about 4 feet tall. And then apparently there was this thing. These don't exist anymore, but these were 1.8 meters taller than humans. That is terrifying. So this is how we're going to be talking about lengths now in terms of meters. Okay. And then we have mass, which is kind of, you can think about as weight. And the base unit for mass is grams. And you can measure weight or mass using a scale. So here I see I have a bunch of potatoes on the scale on the left. And it's kind of blurry, but this looks like it's about 700 grams. So the potatoes are 700 grams. And then I see over here the bag of flour is 2 kilograms. Okay, so both of those are using grams, but I can see I have grams and then kilograms in the other. We're going to talk more about that later. But this is what mass is, how much something kind of weighs. And then finally, volume. Volume is the amount of like a liquid or of an object, free-flowing object that can fit into a space. So volume is like the capacity. And the base unit for volume is liters, and you can measure volume in a cylinder or a flask or something that can hold the capacity of the object, right? And so here I just have a 1 liter and a 2 liter bottle of soda. So 2 liter is obviously bigger than a 1 liter bottle of soda, right? But this is one measurement that you're already using whenever you drink soda. Okay. So let's break this down a little bit more. So as I talked about, we have like kilograms and grams, right? But there's a lot of other titles in between that as well. So right here is my base. Here's my meter, liter, and gram. That is like the base unit. And then if I want that unit to get bigger or smaller, I can add different, what's that word when you add it to the front of the word? You can add different, so for instance, I have deca, hecto, and kilo. So this means I'm getting larger than the meter unit, okay? So a decameter is 10 times larger than a meter. And then a hectometer is 100 times larger. And then a kilometer is 1,000 times bigger than a meter. And then same thing with liter or grams, okay? So a kilogram is 1,000 times bigger than a gram. Okay? So as I go to the left, the units of measurement get bigger. As I go to the right, the units of measurement get smaller. So a decigram is 10 times smaller than a gram. A centigram is 100 times smaller than a gram. And a milligram is 1,000 times smaller than a gram. Okay? But they all relate together by being 10 times bigger or 10 times smaller than the one before. Okay? So this is a lot of notes, but please copy this down. As you're writing, I think you'll begin to see the pattern a little bit better. And this thing at the top is kind of just to help you remember the order. So this is kind of like how we remember please excuse my dear Aunt Sally for PEMDAS, right? So to remember PEMDAS, we can think, please excuse my dear Aunt Sally. So to remember all the units in the metric system, we can say King Henry died unusually drinking chocolate milk. So king for kilo, Henry hecto, died deca. Unusually is just whatever unit we have, the meter, the liter, the gram. Drinking is deci, chocolate is centi, and milk is milli. Okay, so please write these down and start digesting this as you go. All right, let's go do some examples on the metric system. So whenever I have to do a problem of this, to be honest, I need a good reminder. And so at the top of the page, I'm just going to remind myself of what the units are. So I'm going to start off saying my King Henry died unusually drinking chocolate milk. And so that's my kilograms, my hectograms, my decagrams, then just my base unit, then decigrams, centigrams, and then my milligrams, right? So there's all my units just at the top. Quick reminder. And then I'm also going to remind myself, okay, that as I move different ways, so as I move to the right on the graph, as I go this way, sorry, that's the left. So as I move left here, as my units get bigger, in order to convert between them, I will actually end up divide by 10 for every unit. And then as I go to the right, as I move right, I'm going to multiply by 10 per unit, okay? So let me show you what this looks like. Let me prove this to you. So question 1. It starts off with a reminder that any distance that measures length will use meters as the base unit. And then I'm asked to convert 0.02 kilometers to meters. Okay, so I start off with 0.02 kilometers. So km. To go from kilometers to meters, my base unit, I have to move one. Oh, that was ugly. I have to move over 1, 2, 3. So every time I move to the right, I have to multiply by 10. Okay, so I'm multiplying by 10 3 times, which is 1,000. So I'm going to say there's 1,000 meters for 1 kilometer. So there's 1,000 meters for 1 kilometer. I'm multiplying by 1,000. My kilometers go away. So I have 0.02 times 1,000 meters. And then an easy way to multiply by like thousands is however many zeros you have. So in this case I have 1, 2, 3 zeros. That's how many times you move the decimal place over. So if my decimal place was right there, I'm moving it over 1, 2, 3 to now be there. So my new number is 20 because that's where my new decimal place is. So this is 20 meters. Okay. Let's do some more. Hopefully this is a little familiar from chemistry or Algebra 1, but let's keep doing examples. So example 2, any volume measurement will use liters as the base unit. Convert 315, this says 315 centiliters to liters. Okay, so I'm going to erase that. Now I'm going from centiliters to liters. So now I'm starting here and I'm going 2 to the left. So I'm going 2 to the left. So as I go to the left, I divide by 10. So I'm going to take my 315 liters and I'm going to multiply 1 centiliter to 100 liters. So I'm dividing by 10 twice, which is the same as dividing by 100. Okay, so my liters cancel out. I'm left with 315 centiliters divided by 100. When I divide, basically now I can move that decimal place that was right here, so it was right there, divide by 100 since there are 2 zeros right there. That means I can move the decimal place 2 to the left. So this is 3.15 centiliters. Okay, so just as I moved over 2 to the left there, essentially my decimal place is just moving 2 to the left. I'm showing you the long process so you can see everything that's happening, but basically I just moved the decimal place over 2 to the left. It's a big secret, okay? Alright, let's look at the last one. So the last example reminds you that any weight measurement uses grams as the base unit. Convert 2 hectograms to decigrams. 2 hectograms to decigrams. So I'm starting off with 2 hectograms and looking at my chart to go from hectograms, and now I need to be careful, to decigrams, not deca. I go all the way 1, 2, 3. So I have to go over 3 spaces. Okay? As I go to the right, I multiply by 10. So I can say there are 1,000 decagrams for 1 hectogram. My hectograms cancel out. I'm left with 2,000 decagrams. So again, I showed you the whole process, but I do want you to be able to look at this and see, okay, hectograms, 1, 2, 3 to decigrams, and that decimal place was right here for 2. It moved over 1, 2, 3 decimal places. Okay, that's a little shortcut for you. I'm showing you all the work, but if you understand the shortcut, you can use the shortcut. Okay, so I want you to try this on your own right here. So 2 problems, they're multiple choice. I want you to apply the same thing that we just did. I always recommend King Henry died unexpectedly drinking chocolate milk. That always helps me if I write it at the top of my page, and then going from hectograms for centigrams, I can kind of count how far it takes to go over, left or right. You got it. Give it a go. We'll continue practicing this a little bit more in class.